Okay, so in this video, we're going to talk about algebra review. We're going to do some solving of equations as well as simplifying radicals. When solving equations, you want to move all your like terms to the same side. So I'm going to underline my variables and I'm going to circle my numbers and I'm going to move them all to the same side. So I'm going to subtract 4x from both sides. So I'm going to get 7 equals x, and due to the reflexive property, we can switch that around so that x equals 7. Okay, here now we have terms on both sides. Again, I'm going to underline my variables, circle my numbers, so I need all my circles on one side and all my underlines on the other. I like things to be positive, so I'm going to add 6x to both sides. So I'm going to get 14x plus 3 equals 45. My circles are still not on the same side, so I'm going to subtract 3. So I get 14x equals 42. Then I'm going to divide by 14. So we will get x to equal 3. Okay, again, here we are still having a little more happening. You're going to combine terms on the same side before you start moving things around. Okay, so I have a 3x and a 2x, which gives me 5x plus 15 equals 55 minus 5x. Again, I'm going to underline and circle. Okay, I'm going to add 5x to both sides. So I get 10x plus 15 equals 55. Subtract 15 from both sides. So 10x equals 40, and then divide by 10. So x will equal 4. Okay, last example here for solving. We want to distribute before we do anything else. So we're going to distribute the 2 to the 3x and to the 8. So we're going to have 6x plus 16. Remember, when we distribute, we're multiplying. Okay, and then again, I'm going to underline my variables, circle my numbers. I'm going to add x to both sides. And then I'm going to subtract 16 from both sides. So I'm going to get negative 21. Please be careful with your negatives. Make sure you do not lose them. Divide by 7. So we get x equals negative 3. Okay, so that's it for solving. If you have any questions about it, please come in and ask. Okay, next we're going to talk about simplifying radicals. Depending on who your teacher was last year, depending on how you solved radicals, you can either use factor tree or you can use birthday cake. I'm going to demonstrate birthday cake on one example here, and I'm going to demonstrate the factor tree on the other. Please use whatever works best for you. It is a preference. So when solving, I'm going to do birthday cake first. You want to take 54 and divide it by a prime number. So I'm going to divide 54 by 2. And when I do that, I get 27. Now 2 doesn't go into 27, but 3 does. So I'm going to divide by 3, and I'm going to get 9. 3 goes into 9 again. And then 3 goes into 3. And we get 1 at the top. So it looks like a birthday cake. Okay, then I'm going to rewrite my terms out. So I've got 3 times 3 times 3 times 2. I'm going to circle any pairs. Those are going to now come outside of my radical as one number. So if I had had 2 pairs, right, I would have had 3 times 3, but I only have 1. So I'm going to put 3 on the outside. And then what's left goes back on the inside. So 3 times 2 is 6. Okay, so 3 square root of 6 would be the simplified version of that radical. Now here I'm going to use factor tree, okay? And it's the same process. You take a prime number that goes into 160, so I'm going to say 2, and we get 80, and then I'm going to say 2 again. We get 40, I'm going to say 2 again. We get 20. Let's say 2 again, we get 2 and 10. And then I'm going to say 2 again, because we get 2 and 5. Okay, and now I'm all the way down. 5 and 2 are both prime numbers. So I'm going to rewrite it. So I have 2 times 2 times 2 times 2 times 2 times 5. Okay, so I have one pair of 2's and another pair of 2's. So that's 2 times 2 on the outside of the radical, and 2 times 5 on the inside, or 10. So I'm going to get 4 square root of 10 as the simplified form of my radical. Again, you can solve these using either method. It's whatever works best for you.